In this video, I'm going to be talking about the natural logarithm function, and I'm going to work through some differentiation problems dealing with the natural log. I'll put down in the video description where you can jump ahead to that if you don't want to see the introduction. But anyway, I'm going to get started. So it turns out we define the natural logarithm function, and the way we define it is by this equation right here, which states that the natural log of x is equal to the integral from 1 to x of 1 over t dt when x is greater than 0. So over here, the graph of y equals 1 over t is this curve right here. And when we take the integral from 1 to x, the area underneath the curve is equal to the natural log of x when x is greater than 1. Now, if we have x is greater than 0 but less than 1, the area underneath the curve from x to 1 of y equals 1 over t is equal to the natural log of the absolute value of x. So that is just the definition of the natural log of x. Now, we also have the definition of e, the number 2.71828, etc. And its definition is the natural log of e is equal to the integral from 1 to e of 1 over t with respect to t, and that turns out to be 1. So the area underneath the curve, y equals 1 over t, from 1 to e is equal to 1. So those are just basic definitions for the natural log and for e. Moving forward, I'm going to do some review here, just some basic logarithm functions, so you can, logarithm properties I should say. The natural log of 1 is equal to 0. The natural log of a times b is equal to the natural log of a plus the natural log of b. The natural log of a to the n is equal to n times the natural log of a. And finally, the natural log of a divided by b is equal to the natural log of a minus the natural log of b. And that should just be a review from pre-calculus. You can find out how these are derived elsewhere. But just something to keep in mind as we're going through some of these problems. Now, derivatives, what we'll be using for these problems, the derivative of the natural log of x, it turns out that that is equal to just 1 over x when, as we saw from the graphs, x is greater than 0. Also, the derivative of the natural log of u is equal to 1 over u times the derivative of u with respect to x. And of course, we can also write that as u prime over u. And this is also when u is greater than 0. Finally, the derivative of the pen's getting a little out of control here. Natural log of absolute value of u is equal to 1 over u times the derivative of u with respect to x, which is the same as we had for the natural log of u, the derivative of the natural log of u. So we can also write that as u prime over u. So these two, the derivative of the natural log of u, the derivative of the natural log of absolute value of u, are equivalent. So, with the definitions in place, we can go ahead and do some problems. So for the first one, I have y is equal to the natural log of x to the third plus 1. Now to take the derivative of that, we can do a few things. The first thing I would do is write y prime is equal to, well, what do we have here? We have the natural log of something, because this is an expression, it's a function of itself, in itself. So in order to do that, we have to take the natural log of u times the derivative of the inside. So it would be in the form 1 over u times du over dx. So that just means that whatever's inside of here is u. So in order to do that, we just take this and write 1 over x cubed plus 1 times du over dx of x cubed plus 1. And we know that that is the same thing as 1 over x cubed plus 1 times 3x squared, and that is just equal to 3x squared over x cubed plus 1. So that is our final answer. And another one. For y is equal to the natural log of the absolute value of sine x. This also deals with u. I guess u is equal to the absolute value of sine x. No, it's equal to the absolute. I'll write it out. U is equal to sine x. So in order to do this, we know that the form will be 1 over u times du over dx. And in order to do that, we can simply write it as y prime is equal to 1 over sine of x times du over dx of the, well, we can get rid of the absolute value signs because the definition is the same whether it's the absolute value or not. So the derivative of the sine of x. And that is going to be equal to 1 over sine of x times, well, du over dx of sine of x is just cosine of x. And cosine of x over sine of x is equal to 1 over tangent of x, which is equal to cotangent of x. And that is our final answer. Moving right along, if f of x is equal to the square root of the natural log of x, what is the derivative? Okay. Well, f prime of x is going to be equal to, there's got to be a way we can rewrite this. So we could write it as the natural log, well, it'd be the derivative of the natural log of x. Well, the square root of x is just x to the 1/2, so we can write the natural log of x to the 1/2. And I guess this is just going to be a chain rule problem, so we can write it as f prime of x is equal to derivative of the outside 1/2 times the natural log of x to the negative 1/2. That's the derivative of the outside. times the derivative of the inside, which is the derivative of the natural log of x, which is 1 over x. So for our final answer, we should have 1 over 2 times x times the square root of the natural log of x. So what we did here is we just multiplied these two bottom numbers, and since this is the natural log of x to the negative 1/2, we know that it will be the square root underneath on the numerator side. So this is our final answer. And let's try a different type. If we have y is equal to, actually I need more space for this. If we have y is equal to x to the 3/4 power times the square root of x squared plus 1 divided by 3x plus 2 to the 5th power, what can we do to take the derivative of this? Well, we can use logs, and it turns out that if you take the log of one side to make it simpler, then you have to take the log of both sides. So in order to simplify this, I would write it as the natural log of y is equal to the natural log. Well, from log properties, we know that the natural log of x to the 3/4 times the square root of x squared plus 1 would be the natural log of x to the 3/4 plus the natural log of the square root of x squared plus 1. So if you're dividing by the natural log, we distributed the natural log to each piece, then this would be minus the natural log of 3x plus 2 to the 5th, because if you have the natural log of a divided by b is equal to the natural log of a minus the natural log of b. So now I think we can rewrite this a bit more, so we can rewrite it as the natural log of y is equal to 3/4 times the natural log of x. That's because the natural log of x to the n is equal to n times the natural log of x, plus, well, the square root of x squared plus 1 is really x squared plus 1 to the 1/2, so we can take the 1/2 out front, times the natural log of x squared plus 1 minus, there's a 5 to the 5th power, so we can bring the 5 out front, times the natural log of 3x plus 2. And I think that's all the simpler we can get it, so we might as well take the derivative now. If we take the derivative of the natural log of y, we'll have 1 over y times, because it's if it's y, then we have to have with dy over dx, it's with respect to x, is equal to 3/4. Well, the derivative of the natural log of x is just 1 over x plus 1/2 times, let's see, it'd be 1 over u du dx, so 1 over x squared plus 1 times du over dx is just going to be 2x minus 5 times 1 over u du dx, 1 over 3x plus 2 times 3. So that is our derivative, and now it's just a matter of cleaning it up. 1 over y times dy over dx is equal to 3 over 4x plus, well, these 2's can cancel, so we're just left with an x over x squared plus 1 minus that's 5 times 3, 15 over 3x plus 2. Now, it looks to me like this could be rewritten, but it would be a mess, so I don't think I will. Now what we have is we need to multiply this entire thing by y, so we can get rid of the y on that side, and that means our final answer will be 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. And we know what y is from the original problem. It was x to the 3/4 power times the square root of x squared plus 1 over 3x plus 2 to the 5th power. So we've taken the derivative, we've multiplied it by y, so dy over dx of this equation is equal to this. And it's messy, but it is the final answer.